This is an introduction to the cell cycle. Look at this chair. Look at this table. Look at this bacteria. And finally, look at Mr. Sewell. Everything is full of cells. A cell could be from this small, 1 micrometer, to this small, 5 micrometers. That's what a bacteria is. Usually there isn't just one cell in a human body. There are tons of them. It really started from the cell division, which the G0 phase is an alternative phase that the cell could go through if they do not want to divide for certain reasons. So they go out of the cell. During the S phase, which is the next stage of the cell cycle, DNA replication happens in that phase, and everything needs to be copied carefully in order to prevent cell death. Originally, we have 23 chromosomes, and after the DNA replication, we have 46. So after the S phase, we have the G2 phase, which is a process of where everything has to be consolidated in order for mitosis to occur. Most genetic codes are made into proteins. They also make the microtubules that are needed during the mitosis in the G2 phase. Mitosis is the final stage of the cell cycle. This is where the cell splits into two. You could actually see its chromosomes splitting when it divides. After it is finished, then most of the cells go into their own cell cycle. And some of those cells, which in this case would go to G0 phase, but most cells actually go through its own cell cycle again in order to divide. So therefore dividing and dividing until they can't divide anymore. A major type of protein plays a major role in the cell cycle, which is the cyclin and its enzyme, CDK, cyclin-dependent kinase. When combined, these two create MPF, maturation promoting factor. You need a lot of maturation promoting factor in order to make the cell go to the next stage. So, in order to proceed, the cell must have enough maturation promoting factor. So, usually there's a lot of cyclin-dependent kinases, but it is also inactive. In order for it to be activated, it must have cyclin. Metabolic rate is how fast we can digest, or not how fast we can digest, but how fast we can burn the calories in our body in order for it to be used into ATP. How much calories are in this donut? How fast can we digest this corn? Can we digest corn at all? The calories in this donut is going to be broken down into ATP, or broken down after several processes into ATP, which is our main energy source. The human body burns calories in order to sustain the vital needs of breathing, blood circulation, and activities within the organ. We burn calories by walking, working out, or playing a sport. These are ways to burn energy to give us energy such as ADP, adenosine triphosphate. We were talking about metabolism rate. Thyroxine actually influences the amount of the rate of metabolism. First off, since thyroxine are in the hormones in the bloodstream, they're going to be attached to protein receptors. Plasma globulin. Thyroxine then increases the activity of mitochondria in cells by binding to a specific section of DNA, then increases the rate of carbohydrate metabolism and a rise in the rate of protein synthesis and breakdown. This is a picture of protein receptors attached to thyroxine, or thyroxine attached to protein receptors, going into a specific section of DNA to influence it. Thyroxine is actually regulated by a thyrotropin in the pituitary gland, which is in the brain. However, back to metabolism. Sometimes too many thyroxines get into your bloodstream, which causes really high breakdown of calories. Therefore, there will be sudden weight loss, blood rate increases, and then there would be swelling in the neck, which is called thyrotoxicosis, which can cause menstrual increases and swelling in the neck. because the thyroid gland is swelling, which it protrudes out onto your neck and everyone can see it. Too little thyroxine is a bad sign as well. It could cause weight gain and there's something called hypothyroidism. It actually is very logical. Think about it. If your body is not burning calories, then all the calories that you eat is going to sit in there, and you're going to grow, and then you're going to gain weight. So therefore you would become like an elderly because they burn little calories, and that's why they get fat. So there isn't much energy in them, so that's why there is low ATP. And there's an experimentation on mice in Japan of where metabolism rate is involved and how it decreases as age increases. There's a negative inhibition or a negative feedback on the metabolism rate. Neurons in the hypothalamus secrete thyroid-releasing hormones, TRH, which stimulates cells in the pituitary gland to secrete thyroid-stimulatory gland. TSH binds to receptors on the thyroid gland, stimulating thyroid hormones, which affects all cells in the body. When blood concentration of thyroid hormone, TRH, neurons in the hypothalamus are stopped, and stop making TRH, which you can see here where it starts when thyroxine actually increases in level, then there's a loop that it goes through, and it goes to the interior pituitary. This is the ovarian cycle. The ovarian cycle happens in a woman every month if natural. It occurs to make pregnancy possible. Every month, the woman goes around a menstrual cycle unless they are pregnant. We are focused on the ovarian cycle today. It is divided into 2 weeks at the top. The first 2 weeks are called the pre-ovulatory phase. There is a hormone from the pituitary gland. Follicle-stimulating hormone secreted by the hypothalamus stimulates the growth of the ovarian follicle, which makes it secrete a hormone called estrogen. FSH causes follicle cells to make estrogen or insert it into the bloodstream. FSH activates follicle cells with FSH receptor sites. After day 14, during day 14 to 28, it is called the post-ovulatory cycle because the egg is popped out before day 14. So therefore, it leaves us with the follicle cells. Now it is called corpus luteum. And now the pituitary gland actually creates a different type of substance called LH. LH is a different type of hormone because it has a different receptor site and it uses follicle cells instead of follicle cells and the egg. So therefore, that's the difference of why it would create a different type of substance instead of just estrogen. LH hormones create something called progesterone. Progesterone is called progesterone because it is preparing the woman's body for pregnancy, therefore causing increase in blood vessels as well as having the egg in the fallopian tube. Therefore, the egg actually is fertilized in the fallopian tube instead of in the uterus. The way how progesterone is created is that LH signals the corpus luteum, the follicle cells without the egg, and therefore its different receptor sites, and its receptor sites causes it to make progesterone. So there's a negative feedback loop of FSH, as mentioned before. It is the first 14 days of the ovarian cycle. So when the FSH increases, the amount of estrogen in the bloodstream increases as well. But when there's a high enough amount of estrogen inside the bloodstream, it inhibits the pituitary gland from releasing FSH. So therefore, the egg cannot be fertilized or dropped out because the estrogen is inhibiting the FSH. So not enough FSH will not allow the pituitary gland to create more. And it doesn't allow the egg to pop out. So therefore, that is a negative feedback loop. So when you take birth control pills, it actually stops the creation of FSH because when you're taking in those birth control pills, there's a type that says estrogen and there's a type that says progesterone. So the increase in estrogen when you're taking those pills in, it stops the FSH from releasing. So therefore, it prevents the releasing of the egg. So all the other cycles, there could be causes of where there's too much FSH produced. Then pregnancy is impossible because too much estrogen is produced, just like the negative feedback. So with having a lot of estrogen in the bloodstream, it inhibits the production of FSH, preventing pregnancy. As said, that it prevents the egg from dropping out from the first or the pre-ovulatory cycle. This is what happens when you take estrogen pills. Therefore, you would have a normal menstrual cycle instead of having pregnancy. Too low estrogen, FSH, could cause very much egg fertilization. That's how twins actually come about. The ovary has too many eggs in the body, so it doesn't need to work hard to control ovulation to get a normal ovulation. If the egg number is low, then the condition of FSH is increased to get ovulation or to push ovaries. Thank you everyone for watching this video on the ovarian cycle, the cell cycle, and metabolism rate.